Okay, we are concerned with finding the minimum of two independent random variables x and y. X and y are both independent random variables, and the application of such a probability will lie if we are concerned in finding the reliability of a series circuit. If two components A and B are connected in series, and we need to consider the reliability, then we will have to consider the minimum of the two probabilities, or minimum of the two reliabilities. If with X we represent the reliability of system A, and with Y we represent the reliability of system B, then the reliability will be determined by the minimum of the two, since they are connected in series. So we need to find the CDF and the PDF of the minimum of the two probabilities, that is U. U is represented as minimum of the two independent random variables x and y, and we are concerned with finding the CDF and PDF of U. Okay, so in order to find this, we will start with the procedures discussed before, that the CDF of U will be given by probability of U less than or equal to U, which implies probability of minimum of x and y less than or equal to U. Now either x, if x is the minimum of the two random variables, then x will be less than or equal to U, then obviously x will be less than equal to y. Or if y is the minimum of the two independent random variables, then y will be less than or equal to U, and in that case x will be greater than y. So we have the union of these two events, either this event or this event. So these two events are in union. And we know from previous formula that probability of A union B will be given by probability of A plus probability of B minus probability of A intersection B. So if we use this formula for this case, what we end up with, since we are considering this as A and this as B, so what we end up with is this probability, that is probability of x less than or equal to U plus probability of y less than or equal to U, that is probability of A plus probability of B, minus probability of A intersection B, which is probability of x and y both less than or equal to U. X less than equal to U and y is also less than equal to U. So if we write these probabilities in terms of their CDF, this becomes fxu, this becomes fyu, and this will become, from joint CDF concept, fxyuu. So we get f of u, that is the CDF of u given by the CDF of x evaluated at u plus the CDF of y evaluated at u and the joint CDF of x and y evaluated at u and u. So from the CDF, since we know x and y are independent, and we know for independent random variables, if the joint CDF can be written as the multiplication of the two marginal CDFs. So from this we can write this. Since x and y are independent, the joint CDF can be split into the multiplication of the two marginal CDFs. So from now we get fu equal to fxu plus fyu minus fxu into fyu. And this is the CDF of the minimum of the two independent random variables. Now in order to find the PDF, we have to differentiate the CDF. So since the CDF is in terms of U, the PDF will also be in terms of U. So we must differentiate the CDF in terms of U. So if we carry out this differentiation, this term will simply become the PDF of x evaluated at U. This will become the PDF of y evaluated at U. And both these terms, since they are differentiable by U, we have to carry out the UV rule of differentiation. So first we keep fyu constant and differentiate fxu. So we get the PDF of u multiplied by the CDF of u evaluated at y. Next we keep the CDF of x evaluated at u constant and differentiate the CDF of y evaluated at u. So we get fxu for the CDF into the PDF of y evaluated at u. So finally, if we take fxu common from these two terms, we will get fxu into 1 minus fyu. And if we take fyu common from these two terms, we get fyu into 1 minus fxu. So we end up getting the CDF and PDF of the minimum of the two independent random variables. Similarly, there exists the maximum of two independent random variables, and this probability or this concept can be used to model the reliability of two systems connected in parallel. If A and B are two systems connected in parallel and X represents, for example, the reliability of system A and Y represents the reliability of system B, then the reliability of the overall system will be given by the maximum of these two components. Since if one component fails, the other component, if it works, the system will still work. So the maximum of the two reliability will be the overall reliability of the system. So in order to find the maximum of the two reliabilities, we represent W as the maximum of these two independent random variables. W is given by max of X and Y. So again, if we follow the previous procedures for finding the CDF and PDF, to find the CDF of W, we write probability of W less than or equal to W, which is given by probability of max xy less than or equal to W. Now, in this case, there will not be any one of two different events, because if any one of the two random variables is the maximum, it is less than or equal to W, then automatically the other random variable will also be less than or equal to W. Let me repeat again, if any of these two random variables, X or Y, is less than or equal to W, since we are finding the maximum of the two independent random variables, automatically the other one will be less than or equal to W. So we will have the intersection of these two events. That is, if X is less than or equal to W, it is the maximum of X and Y, then automatically Y will also be less than or equal to W. Similarly, if Y is the maximum of X and Y and it is less than or equal to W, X will automatically be less than or equal to W. So we will always have an intersection of X less than or equal to W and Y less than or equal to W. And from definition, this is simply given as the joint CDF of X and Y evaluated at W and W from the basic definition. So we have obtained the CDF. In order to obtain the PDF, we must differentiate the CDF. So we can at first easily split the joint CDF, since X and Y are independent random variables, into their marginal CDFs, as discussed before, since X and Y are independent. So if we carry out differentiation of this CDF to obtain the PDF, again using the UV rule of differentiation, first we keep FYW constant and differentiate FXW, we get PDF of X evaluated W into the CDF of Y evaluated W. Then if we keep this term constant, that is the CDF of X evaluated W, and differentiate the other term, we get the CDF of X evaluated at W into the PDF of Y evaluated at W. So we obtain the PDF and the CDF of the maximum of the two independent random variables.